Hello, and welcome developers to this training exercise on how to use Git. In this exercise, we will cover what is Git, how Git works, changing code and pushing it to a repository, and finally, looking at an overview of how staging works. Before we dive in on what Git is, we must first understand what fundamental problems arose in the first place that led to the need for Git. Let's say there is two developers. One's name is Alan and another named Jeff. Both of them work at the same company and have access to the same database. The boss calls both of them up and tells them a particular file in the database needs to be looked at and changed. Both Jeff and Alan agree and head off to their workstations to start editing bits and pieces of the code. Jeff has had a couple of new lines of code and he submits them to the database to be changed. However, Alan also has new lines of code, different from Jeff's, and also doesn't include some of Jeff's fixes. Now the database has a problem. Does it accept Jeff's file or Alan's? Which one is correct? If it takes Jeff's first, does Alan's file overwrite his after submitting it to the database? In fact, the only way to really solve the problem is have Jeff work on his piece of code first, then submit it, and have Alan take a look at it later, and then add his code and submit. However, that would leave Alan waiting on Jeff's work with nothing else to do in between. Neither developer can work independently and without causing conflicts. To solve this problem, software developers have been using version control programs to help keep track of files to avoid these conflicts and keep the database clean. This leads us to the development and use of Git. Git is a software tool designed to give developers version control over their codebase, also known as a repository. One of the features of this tool is it keeps the codebase's integrity by handling conflicts. It also lets multiple developers work on a project independently as it tracks all the changes made to the main repository. Let's take a quick overview of how this looks. The main repository, aka your code, sits somewhere on a server such as Bitbucket. From there, anyone who you grant access to can pull your code or repository down to their local machine. Once they have a copy of your repository, they can then begin to independently edit and change files. These changes can be anything like bug fixes, patches, new and extra features, and so forth. Once they are done changing their files, they can then submit a request to you, the owner of the main repository, to pull their changes into your main codebase, effectively updating it. When your main repository gets updated, anyone who pulls down your repository afterwards will also get the new changes. This allows multiple people to work on large projects and to effectively maintain all the changes occurring. Now that we covered the fundamental problem developers run into with code management and why Git is a useful and necessary tool, let's get started with learning how to use Git to make our changes to the repository. Here on your screen is two windows. This is what you as a developer should see after logging into your SSH software tool. In my case, I am using Bitwise. The window at the top is your command line interface or shell. It's also referred to as the terminal. The window on the bottom is your graphical user interface, GUI, or pronounced GUI for short. That is an alternative to using the terminal window. Looking at the GUI split screen, the panel on the left is my local files on my desktop. The panel on the right is the server-side code. I can do things a graphical interface provides, such as dragging and dropping files into folders as opposed to the terminal, where I would have to write the command out. Which one you use is up to your preference, but I personally use both, depending on which one will get me to my destination faster. Once you have logged into Bitwise, your starting location should be your user home directory. In my case, it's root. Let's take a look at Git now and see what happens. In your terminal, type git status. As you can see on the screen, it gives us the following error: fatal, not a Git repository. Your Git repository is located in your Drupal site installation. So in order to check the status, We must be in that directory for the command to work. If you look at our current location, you can see that we are in the user directory. Let's navigate to the Drupal directory. Click the Up folder icon to go up a level in the directory. This is our base directory. From here, click on var. From var, click on www at the bottom of the list. Lastly, click on the ERC360 folder. Depending on what server you logged onto, this name may be different. This is what inside our Drupal directory looks like. This is where all the code for our website is stored. If you look closely at the top of the list, a Git folder is present. This is the folder that tracks all the changes you make to your files on the Drupal server, and also part of the reason why you need to be in the proper directory for your Git commands to work. However, just because we traverse through the directory on the GUI does not mean we are in the same directory on the terminal. They are two separate entities independent of one another. Let's go ahead and get to the same location using the terminal. Inside your terminal, type cd followed by the direct path to your Drupal site. CD stands for Change Directory. If the path is valid, your terminal should update your current standing directory. Now that we're in the right place, let's again try Git Status. This website has already had some modifications done to it, so it lists what those changes were. Let's go through what we are seeing. The first line tells us what branch we are on, and in this case, the master branch. This is typically used as your primary codebase of the repository. You can also have other branches that branch off from master. The second line focuses on files not staged for commit. Files that are not staged will not be committed when you push your code forward. This is not to say that the files will not be tracked, but rather that they will not be updated to the main core database because you did not put them in the staging area. Files you do not wish to be pushed forward can remain unstaged. If you look closely at the files, 2 are deleted and 1 modified. Deleted status means the file was once in the directory, but is no longer there. Modified means the file is still in the directory, but the code has changed, signaling it's been modified. Let's go ahead and do some of our own modifying of files by changing the CSS theme of our website. The navigational banner is blue, and we will go ahead and set this to purple. In the GUI, I traversed from the Drupal site inside the CSS theme folder. Here, I found a CSS template that sets the color of our navigational banner. On the screen, you should see the top blue banner of our website along with the CSS file I opened up to make some changes. I want to modify the CSS file so that our website goes from blue to purple. Inside the CSS code, I commented out the old code on line 10 through 13 that set the color to blue and replaced it with the new color of purple on lines 6 through 8 and saved the changes. Now that my changes are saved, let's go back to the terminal, type git status, and see the results. Here you can see that my changes to the CSS code shows up now in the modified state. Git has a history of the original CSS file and its current state. When I edited the file, it noticed that the content has been altered and therefore set it as modified. Now I have two options. I can let the CSS file remain unstaged, which means when I commit my code, those changes won't be picked up. Or I can stage the file, which will add it to my next commit, and when I push the code forward, it will update the CSS code on the website. Let's go ahead and add the file to the staging area. To add a file to the staging area, type git add followed by the file name. If you look at the example on the screen, you'll notice I got a fatal error message reading the path. That's because if you want to add a file, you also have to give it the directory path. Let's try again, but this time with the file path. After typing in the file path, hit enter. You'll notice it doesn't give you any indication that the file was added. In order to check that the file was staged, we have to do git status again. Here we can see in green that the file has been successfully staged and ready to be committed. If you don't want specific files to be committed, you can also remove them from the staging area if you made a mistake. For a full list of commands, type git help to see what options are available to you. You can also go to the Git website for further documentation. Now that our CSS file is staged, let's go ahead and commit it. Type the following command, git commit -m, followed with a small description of what your committed code is about. The -m in the command stands for message. In my case, the committed code is for tutorial purposes only, so I'm letting developers know that they can actually disregard my changes. But in case this was a real scenario, I would put something along the lines of updated CSS theme or updating banner color. If you are constantly updating a specific file, you can put version numbers like v1.0 or v1.2 or so on. Once you're done typing the git command, hit enter to submit your code. If successful, you should get a small report on number of files changed, how many insertions and how many deletions. You may wonder why 6 insertions when I only updated one CSS file, and why 1 deletion when I didn't delete any files. This has to do with how Git tracks file changes inside the file itself, and I will show you an image in another slide shortly on how this looks to Git. For now, let's push our changes to the main repository. In order for your commit to be pushed to the main repository, you need to type the following command, git push origin master. Keep in mind this may be different if you're on a different branch. So you would otherwise say git push origin followed by the branch name. After you input the command, hit enter. Git should then proceed to start updating the main repository with your code. Congrats, you've successfully submitted your first commit. Once done, you should be able to see your changes on Bitbucket. Let's go over there and take a quick look. After signing in and going to my repository, I can view my committed changes from here. Every commit has an ID associated with it, so if you need to roll back to a previous commit, you can. It also has a small message for description of what the commit does. Here's the CSS file we changed. If you look at the top, it has +6 insertions in green and -1 deletions in red. This is how Git looks and tracks files. If new content is added, it's counted as an insertion, and if content is taken away, it counts as a deletion. In my case, it's the deletion of the old blue color in the replacement of the new purple color. Now go to your Drupal site and clear the caches. If done correctly, your main repository should have the updated changes and be displayed on the site. Here, we successfully changed the banner from blue to purple. Now that we've covered how to stage, commit, and push your code from the terminal to your repository, you may wonder how all this works. Why are we staging files? What does commits do when it didn't change the online repository? Why do we need to push? Let's have a quick overview of how staging works. Let's go over a typical user interaction with Git. A user will have likely set up his or her online repository on Bitbucket. This online repository is independent and its own codebase. The local repository is a cloned or pulled down repository from the online repository and rests on the user's home computer or laptop. From there, he or she can edit and change files freely at will, without messing with or changing the online repository. Eventually, the user will have edited some files on their local repository and will want those changes committed to their online repository. The user will then take the edited files and add them to the staging area. The user will then use git add file command to add his or her changes to the staging area. These files are changes that the person wants to commit. After staging all the files necessary, The user will then want to commit their code. Pay close attention here to what happens. The user will input the git commit command followed by a message, and then you will notice that the local repository has updated its files from 1 to 3. The online repository remains unaffected. Only the local database has been changed. Why is this? The Git tracking system works in snapshots. It has a snapshot of your database, so when you make changes, it has a new snapshot. When you commit code, you're not necessarily committing or changing the online repository, but you're updating your own local repository. Now Git has a new image or snapshot of your database. The old one-file database snapshot it held previously is gone or deleted. As far as Git is concerned, the 3-file database is now the new snapshot. So if this is the case, then how do we change our online repository? We do this with the push command. By using git push origin master, we are effectively telling Git to take the current snapshot of our local repository and push that onto our online repository. Once we hit enter to run the push command, the new online repository will be updated with what we have committed. And that is how the staging system works. Thanks for watching this training video on how to use Git. Look for more video tutorials like these in the future from CeriumSoft.